All right, welcome back. I'm not going to read this whole title again because we just read it. This is the second part of the three-part chapter 8 in this book. We're going to talk about searching now. Okay, so we just talked about arrays. All right, so let's say we have an array of numbers. Let's just make up something here. Let's say we have a -2 and a 17 and a 5, 101, 0, and a 3. Okay? Now, your book talks about two different kinds of search. There is a sequential search and a binary search. So we're going to talk about the sequential search first. It's the easier of the two. Basically, how this is going to work. We're going to see how it works, and then we'll see how to code it. Okay. Basically, the sequential search is bone stupid. It's going to start here, and let's say, what are we searching for? Let's say we're searching for 101. That's what we're searching for. It's going to start here with the first one and compare this to this, the -2 to 101. Is that the same? Nope, we haven't found it. Now it's going to try this one. Is 17 equal to 101? Nope. It's going to try this one. And then ding, ding, ding. Finally, on this one, it matches. Or if it's some other number that's like, 109, it'll keep going because it won't find it until it's finally done, and it just wouldn't find it. So it's really simple. You're just literally going through each one. Okay, and there are, like most things in programming, multiple ways of doing this, writing this code. So let's create a method that does this. So let's create our, let's say, pretend it's in a class, right? So I'm going to do this as a method. Public, this is going to return, what should it return? It'll return int. Sequential search. Okay? And what this is going to do, let's see what are we going to have. We're going to first start with the int target. That's what we want to find. And then we're going to pass in the array. So then we're going to say int stuff. Okay? So this is a little fancier than the book. This is actually, I made this a method. So what's it going to do? You pass in the number, like we use 101 over here, so you pass in the 101 here. This stuff is an integer array, so it's the whole array we're going to pass in. And it's going to find whether or not target is in it. Now here's the tricky part. If it finds it, it's going to return the index. So 0 to whatever this is, stuff dot -1, right? It can never be length. It's going to be -1 because we start counting at 0. Right? So it's going to return one of these. Now, if it does not find it, it's going to return -1 here, because -1 is not a valid index. So if it's -1 that you get back, you know it didn't find it. Okay, that's a very common pattern, by the way. Okay, so how do we do that? Well, let's see. Let's try for it. I is equal to 0. I is less than stuff dot length I plus plus. We're gonna put this up here. Boolean found equal false. Okay, because we start off, we haven't found anything yet. Then we're gonna say in here, if stuff sub I, which is how we say it, by the way. In square brackets, we say sub I. So stuff sub I is equal to, double equals for condition, and we're going to compare it to target. And if it's equal, we're going to first of all say found is equal to true. We also have to have something else here too. Maybe I'll just put it up here. We have to say int found index. We have to know where we found it. So we found it, and we're going to say found index. Actually, you know what? We can make this easier. We don't need this. We can say int found index equals -1. So we start off with found index being -1 because we didn't find anything. And so if we match target, we say found index is equal to I. Okay? And at the end of all this, and remember I'm not using squiggly braces because it's only single lines. If there's multiple lines, I need the braces. So I come down here, and I say return found index. So what's going on here? By default, I say, okay, if nothing else happens in this thing, we return -1, meaning we didn't find the number. Now I've got a for loop that goes through the whole length of this thing and compares each one to target. If we find target equals, right? If it matches, I'm going to say found index is equal to I, right here. That's the right one, great. And then when we get down here, we're going to return whatever we found. Found index will either still be -1 if we didn't find it, or if it did, it'll be set to wherever it found it. That works. Now this is not a particularly fancy implementation. It has a few shortcomings. Two actually come to mind. Number one, what if I have more than one target in here? Let's say I have 101 here, okay? Now this is gonna go through the list, and it's gonna find it here, and it's good. So let's put our indexes here just so we're clear. 0, 1, 2, 3, 4, 5. Okay. So when we get to index 2, it's gonna match this. Say yes, it found it. Okay, found index is equal to 2. And then it'll go on to the next one. And then say found index is equal to 3. It'll set that to 3. Okay, and it's gonna return 3 because there's no more matches. Now if that's the behavior you want, that's great. But what if you only wanted the first one? You'd have to do something about that. Another problem with this one is it's going to potentially waste a lot of time. You're going to look at every single one of these boxes, even after you found it. So let's say I could get to 2 here and I found it, yay, I could be done. I don't have to go further. It didn't say find all of them, it just said find one. So I could ignore the rest of this array, and what if this was like, 100,000 elements long? That could be actually a lot of work I could save myself. But this implementation is going to go through all of them, even after I found one. So there's a couple of ways you could fix that. It's not in your book, but give you a freebie. In Java, I'll add these braces for clarity. There's this keyword break. Basically, what that'll do is break you out of a loop, just forcibly, just you're out. And so basically, as soon as we find one, break out of this for loop, and then return found index, just like before. Okay, so what that does is saves us from going any further once we find one, which is not a bad thing. That's actually not a bad implementation. There's a better one though, which involves a while loop. Okay, so here, let's say Boolean. Actually, no, we'll start this here. Int found index equal to -1. Okay, and then here we're going to say int I is equal to 0. And we're going to say while less than stuff length, GTH, and found index is equal to -1. Okay, so we'll talk about here in a minute what we're going to do in the loop, but look at what we've got for condition. So while we're, we haven't gone off the end of the array, while we're still in the array, and also while we haven't found anything yet, found index is still -1, we're going to continue looping. Now remember the rule of while loops, very dangerous. You've got to change something in the condition to let that loop stop eventually. Well, there's two things we can change, this length and whether or not something is found. So let's just do that right here. We'll say if, just like before, stuff I is equal to target, and we'll say found index is equal to I, right? Just like before. So if we mash it, set the index, and then here, regardless, we'll say I++ to increment, the index. So we'll keep looking at, if we don't increment the index, they'll keep looking at the same box of the array, same element again and again and again. That's not what we want. That would be dumb. So we want to increment this in here, okay, and then return found index like before. Okay, now this is slightly better, I guess, because you don't have to have that break. The break is a little violent, right? It's not awful. Maybe if you'd like to read that and it's clearer to you, you can use it. But this is potentially a little tiny bit better. We just have the condition here that either we're going to keep going until we're done with the array, or actually no, I expressed it as an and. You're going to keep going while there's more work to do, while we still have more elements in the array, and we haven't found anything yet. So there's your and. So while those two things are true, we keep going. If one of those two things is false, we stop. So either we've run off the end of the array, we stop, or if we found something, we stop. So we don't do extra work. Okay? So then that means in here, what did I say? We've got to modify the condition elements here so we can stop the while. So there's two places we do that. We do it right here. So if we found the thing, we set found index equal to I, so it's not -1 anymore, it'll stop. That could happen. And one way or the other, we increment I, so we keep progressing along the array, so eventually we'll run out of array and this will stop, this one. So we have two ways that we will ultimately stop, so it's safe. Okay, that's the sequential search. We call it sequential search because it's just going one after the other, after the other, after the other, in order until we find the thing or don't. Okay, not very sophisticated, pretty primitive, really common, really common. All right, that is questions on the sequential search. Is that clear? How sequential search works? Okay. Now we're going to talk about a fancier one. A little tricky. And actually, we're going to have maybe a few more elements out here to make this meaningful. 10, 1, 15. Okay, 5, 6, 7, 9. All right. Now, binary search does this. What it does is cuts the list in half. And it says, okay, I don't want to spend time looking at each and every one. I just want to do half the work at most, maybe less. And I'm going to say, okay, and I'm going to compare, pick one that's roughly in the middle, like this one. And I'm going to say the thing I'm looking for, is it greater than or less than this value, 0. So is 101 greater than or less than? And depending on what the answer is, I'm either going to focus on this half of the list or this half of the list. So does anybody see a problem so far? There's a big one. Well, if I'm comparing like 0 to 101 or 103 to 101 or something like that, and changing my behavior based on whether it's greater than or less than. That's a problem because all these numbers are scrambled up. That's not going to work. So let's change it so it does work. Okay, the first selection search that we used will work on any list at all, any array. This binary search method, the elements have to be sorted. They have to be in order. So let's say, what was it, negative 15, negative 1, 0, 3, 15, or maybe there's a 10, 15, 97, 101, 321, and 999, whatever. Okay, so these numbers are in ascending order. They start negative and they keep getting bigger. Okay, now this starts to make sense. I pick the one in the middle, 10, and I say, okay, I'm looking for 101. Well, if they're in order, I know that it's somewhere on that half of the array, right? Because all these numbers keep getting bigger, so it's somewhere on that side. It's not on this side because the numbers are going to go down. So then what I'll do in my algorithm, an algorithm is basically just like a theory of how this works. It's not code. It's like how do you envision your process working? So in my algorithm, I'm going to now focus on this side of the array. And again, I don't want to search through all these things. I'm going to cut it roughly in half. So maybe that's this one. Okay. I'm going to look again. That's 97. Is 97 greater than or less than or equal to 101? Well, it's less than. So I have to focus on that half again. I don't care about this side. Focus on this side. So I guess just to save myself time, it's gonna cut this in half again. Maybe it lands on what's gonna land here. Okay, if you cut it in half. Okay, 321 is it greater than or less than 100? Well, it's greater, so I know it's back this way, and I'm gonna find it finally. So I've done how many comparisons? 1, 2, 3, 4. I've done 4 comparisons, right, to find this number. That's how much work I've done. In the selection sort, how many would I have to do? Well, potentially up to 10, all of them. Or with my fancier algorithm, in this case, sorted order, it would have been 8. So the binary search on a sorted list is almost always faster than the selection sort or many other kinds of searches. It's always got certain advantages. So that's how this is. You're constantly dividing the list in half and deciding which half of the list you care about. Okay? It's the algorithm. How do we code it? All right. There we go. I'm gonna leverage the code in here basically because it's actually pretty clear. Okay, so we start by initializing several variables in one line. Front, back, and middle. So think of this whole list. Let's erase the confusing lines here at the top. And I'm not going to bother writing all the declaration here, but this is nums. Okay, we've seen before how to declare an array of numbers, right? So imagine that's been done. Okay, so we want a front, a back, and a middle. So the front is going to start here. Back is here. Notice it's the length minus 1. The length is 10. We start counting it with 0, so the last one is actually 9. And middle starts off at 0. That's going to change real fast. Okay. Boolean is found false. Okay, so while front, so that's an equal, back, and Now right here, before we get into the guts of this, we see a familiar pattern. It's a while loop. We looked at that the last time, right? The selection search. And we notice two parts of this condition. And the second part is whether or not the thing is found. So we stop when we found something. So as long as it's false, so as long as it's not found, is found is equal to false, then we keep going, okay? But what's this weird thing? Front is less than or equal to back. Well, you're gonna see here that the guts of this algorithm manipulate this as we keep chopping things in half, right? We keep chopping the sections of the array in half. Eventually, we do that enough, front and back are gonna flip. We're either gonna find it, it could be found, but if we don't find it, front and back are gonna flip. And ultimately, front will be in front of, well, will be after back, which of course is silly. So when that happens, we're done. So one or two things, it's the equivalent of running out of array in the previous example. In this case, we're just doing funny math with front and back. And so we keep dividing this stuff by either moving front or moving back until we get to the end. But if we don't find it first, those two values are going to flip inside out. That's invalid, we stop. All right, okay. All right, here we go. So first thing we do, middle is equal to front plus back divided by 2. Okay. Front plus back is basically cutting in the middle. So in this case, front plus back, 9 divided by 2 is what, 4? 4.5 actually, but we're talking about ints, so you just chop off the decimal point. There's no rounding. There is a function in math class, math.round, I think. But for just ints, it just cuts it off. So 0 plus 9 is 9, divided by 2 is 4. So the middle is going to be right here. Okay? So far so good, right? This is where we are in the code. We've set things up, calculated our first middle. That looks rational. If nums middle All right, so let's look at this piece first before we go on to more. All right, so if nums middle, this one here, that would be 10, okay, is less than the target. Well, the target in our example was 101. So yeah, it's less than the target. So that means we care about this side of the array. How do we do that? Front is equal to middle plus 1. So the front now moves up here. Now that's the new front. Does that make sense? Everybody see? It's important you catch that. Does everybody see what just happened there? I literally shifted my focus. I no longer care about this part of the array. So now front and back are here. Okay, that's what just happened. Okay. There's an else if nums Okay, now this is the other case. Let's put front back over here. Instead of searching for 101, let's say I'm searching for 0. Okay, that would be here. Okay, so in that case, is nums middle here greater than the target? Is the 10 greater than 0? No, it is not. So we fall back down here to the else. If nums middle, which is 10, is that greater than the target? Is 10 greater than 0? Why, yes it is. So in this case, we move back to middle minus 1. That's right here. Back is not here anymore, right? Same thing, we just manipulate front or back depending on whether it's greater or less than. And that's literally how we focus on one half of the array or the other half of the array. Does that make sense? Sort of? Okay. Let's put everything back. Okay, so we've covered chopping it in half one way or the other, but there's the third case, and that is else is found is equal to true. Because if it's not greater, it's not less than, it's equal, which means we've hit the target, we found it, like we were searching for 10. We come in here, very first try, is it greater? Nope. Is it less than? Nope. It's equal. Great, we're done. It pops out of this loop down here, and I think we just return it. Yeah. We can return it at that point. And if we wanted to return the index like we did before, we just return middle. Actually, that's not always true. No, that's not always true. You'd have to write some more code. This is true in this case where it found it. If it finds it, then middle, you'd have to have an if statement like this, I guess. If is found, return middle, else return -1 if it's not found. Okay, that works. All right, so it looks complicated, and that's why I kind of stopped and explained each step, because if you just look at all that, you're like, yeah, that's just a whole bunch of code there. What on earth is going on? Binary search, what's it doing? But literally all it's doing, the meat and potatoes of this thing is right here, right? Because this is testing, I'll use comments, the left, this is the right. Actually, no, we got that backwards. Okay, so in this case, because everything's in order, we know, oh, what I want is on this side. So this chunk of code right here moves front over here. And this one moves, this over here, moves back over here. And like if we're looking for 101 again, let's just play with this a little bit. It's gonna move front over here. Front is now here, okay? Didn't find it, nope, it's gonna iterate back over here. Is front crossed over back? Nope, it did not. Okay, so now we're gonna set middle again. So 5 plus 9 is what? 14? Divided by 2 is 7. So here's middle. Oh, lucky shot. It hit 101 right there. Okay. But again, if it didn't, let's say I'm looking for 97. Okay. Then it's going to do the same thing. It's going to come through and say, oh, okay, num's middle, 101. Is it less than the target? 101 less than 97? No. Is it greater than the target? Yes. Then it's going to move back over here. Right? That's what's going to happen. And then middle is going to be 5 plus 6, that's 11, divided by 2. That's interesting. 11 divided by 2 is going to be 5. It's going to be here. I'll have to play with that. If I did that right, it would never find 97. What would it do? Yeah, the middle would be 5 again. Sure, that's right. So back would become middle minus 1, right? That'd be 6. 5 plus 6 is 11. 11 divided by 2 is 5 in an integer world. So that's there. So next time around, front and back sideways? No, it's still okay. Well, maybe it would find it. If num's middle, no. Is it less than the target? Yeah. Okay, no, maybe it's lower. Well, it's less than the target. 15 is less than 97. So front is equal to middle plus 1. So now I have front and back both pointed here at the same thing. Okay? This is weird, but that's true. Front and back both pointed at the same thing. Now we come around here. Middle is equal to front, back divided by 2, which is 6. 6 plus 6 is 12, divided by 2 is 6. Yeah, no, that works. I was getting scared there for a minute. No, that works. 6 plus 6 divided by 2 is 6. And that would be middle. So now we got middle. Middle, front, and back are all pointed at the same thing. And then it finds it, and we're done. Whew, got nervous there for a minute. Yeah, it's a little complicated. If you really want to understand this, it probably helps to maybe try this a little bit on yourself and see how this works. All right, I think that is the end of searching. Yes, it is. We're done with searching. Thank you.